hard to hear you?
Let me put my AirPods in 1 second.
Sure.
Can you hear me now?
Yep.
Okay. Oh, I was just asking if it's possible to get the recording after so I can go back. Okay, awesome.
Yep.
Thank you.
I can do it as a upload it on YouTube as a private or unlisted video. So
Okay.
so you'll have access to it there.
Okay, awesome.
Okay, so let's see. You first full length one was 496 and full length two, or how much time was between full length one and full length two?
2.5 weeks.
Okay.
I was like, I took the MCAT a while ago in April, and I don't think I studied effectively, so I
How
don't
was
think
your
I was like all over it was a 486.
46? And
Yeah.
you remember the rough breakdown?
Um, they were all below 120. Okay, so I know Psych was PS was 125, and then but my Chem Phys was 122, I believe. Cars was 121, and BB was also like 122. So like around those numbers.
Okay. And then the AAMC full length two. By the way, did you take these full lengths before?
I did, but like
Uh-huh.
like it was like months ago.
So you did all of the AAMC full lengths, you're saying?
Yes.
Okay.
Except the scored and unscored ones.
Okay.
But the
Yeah.
1, 2, and 3 I took, this would have been my second time taking it, and then my 4 and 5 I've only taken it once, like a couple months ago.
So, oh wait, so you
I basically had like a lapse in my studying due to like personal reasons. So there was like a whole bunch of stuff going on. So I wasn't able to really start studying for like till like a month or two ago.
okay. So the you said that you did full length 5, and isn't that the scored one?
1 second, let me just pull it up.
Yep.
I don't really know all the names and everything. Okay. Sorry, 1 second.
Mhm.
I'm like all over the place right now.
It's okay.
Okay, so the scored one, the last time I did it was last December. So I was just not doing that. And then, so is the scored one the fifth one?
Oh yeah. That's
Okay, yeah.
how. But so okay. The unscored, I'm just trying to figure out which test you haven't done ever.
Um, the unscored, I haven't done.
Okay, good.
And then,
Uh-huh.
yeah, I've done all of them, the
Okay.
rest of them, I think. But I haven't really like this time around. Done. I haven't done 4
So
and
your test is on the 14th, right?
yes.
So I think that leaves us with time to do one test, let's say on
Perfect.
the weekend. And so on the weekend, let's have you do, on the 7th or whatever. Is that typically a time when you feel like you can do a full length?
Yeah, I can do a full length anytime. I took a break from all my stuff, so whenever I just try to have a schedule fit for whatever you say, because I've like seen your videos and like seen people improve. So I'm like, okay, maybe I
Oh
need a tutor. So
yeah, yeah.
I'm
So
like, whatever you say. So
let's aim so like yeah, we can go over a lot of stuff today, and
mm,
then on like let's say Saturday you can take the unscored test, the test that you have never taken,
okay.
and that will give us a good idea about where you're at. So
Okay.
now the latest full length two that you took with the 508, that was how recent?
Um, sorry. For full length. Wait, full length two was the first one. Okay. Again, I'm sorry. I
Yeah.
didn't take so the recent one that I took was full length three, the 508. Full
Oh,
length two was 496.
oh, in the email that you sent, I see full length one, 496, full length two, 508.
My bad. I got them.
Three is the one where you got the 508, right?
Yeah, yeah. And that was on the 25th, August 25th.
Okay. Have you reviewed that?
I have reviewed CP and the bio section, and some I kind of skimmed through the
What was
psych section.
breakdown?
Let's see. The breakdown was, sorry, it's loading.
Hmm.
127 for CP, cars was 125, bio was 127, and then psych social was 129.
Got it.
So the thing with this though, like I went from 496 from full length 2 to 508. So I took full length 2 let's see, August 10th. So between like August 10th was like a
Yeah.
week and a half. I did kind of went through content, and then I was just trying to do practice questions and
Got it.
like watch videos, kind of saw like figure out the content and like kind of I'm losing the word, but
Hmm.
get it in my head. And then 25th, I took
Yeah.
the third one. But I'm just like a piece of me is like a very strong piece of me is like I don't know if I like a lot of bullet three I had to guess on
Yeah.
in CP and BB. So I was like, maybe I just got a good score because of that. I'm just trying to get between like 505, 510 area. So I'm just that's where I'm at right now. So
Got it. So, all right, why don't you open that test up and you can show me
okay.
those questions that either, you got wrong and that you don't understand, or the ones that you got right, but you got right, you don't know why you got it right. Like, if
Okay.
you guess.
Okay. Let's see. Okay, let me share my screen. Did you see my screen?
Yep.
Okay. So this was CP. I'm trying to remember. Okay, this one was fine. It just count the carbons that right. Or should we go through everything or just ones that I'm just kind of iffy on?
Yeah, the ones that that you either got wrong or you got right by guessing, or, yeah, if you feel iffy about it.
Okay. Yeah, this one's good. For this one, I just kind of saw that like thermodynamic stability. I just saw that this one was 60% more. Like 4A, compound 4A had more, so I just assumed that it was more stable, but I didn't, there's like no like specific reason why I picked it.
Um, so okay, so since so like first of all, so do you know about like thermodynamic control, kinetic control?
Like, mm, yes, and like kind of know about it, but I don't can't like explain it. But
Oh, okay.
if you can, yeah.
Yep. So basically, let's see. So basically, okay, thermodynamic control will be something where your so thermodynamic quantities deal with stability. So they
Hmm.
include things like uh well, Gibbs free energy,
Hmm.
enthalpy, bond dissociation energy, uh
Right.
things like that. Um so like if we were to think about like a regular reaction here, this is the
Hmm.
reactant, this is the product. So the energy or heat or enthalpy of the reactants gives you the energy of the reactants. This gives you the energy of the products. And then
Hmm.
the difference here is the delta H of the reaction. And these are all thermodynamic quantities. Now,
Okay.
here though, we have our, well, this is the energy of the transition state, which is that hump.
Hmm.
And the hump is activation energy. And although
Right.
it's called activation energy, um, it's not really a type of energy value that we're looking at, like for like thermodynamics.
Hmm.
Because this activation energy, like for instance, a catalyst would lower the activation energy, right?
Right.
And if you lower the activation energy, what happens to that molecule? Like yeah, like what happens to the reaction?
It slows down.
Yeah. Well,
Okay.
if you lower the activation energy, it'll go faster, right?
Yeah. Sorry. Oh.
So like let's try doing it like this. So like here is where is the and this is like energy level or whatever here. So
Hmm. Hmm.
this is the energy level of the reactant,
Right.
right? And then this is the energy level of the product,
The product. Hmm.
right? And then the difference between this energy level of the reactant and the energy level of the product is the delta H, the change
Hmm.
the change in enthalpy for the reaction.
Hmm.
So those are all thermodynamic quantities because they deal with,
Okay.
right?
Right.
But our hump here is above like the energy for the reactant or the product.
Hmm.
And that's our activation energy. And that really represents the energy of that transition state. Now, you could lower that activation energy by using a catalyst,
Hmm.
but that won't change any stability. It won't change the stability of the reactant. It won't change the stability of the product. But what it will do is make the reaction go faster.
Okay.
And that means it's a kinetic quantity. Kinetics, so thermodynamics deals with stability, kinetics deals with uh speed or
Okay.
rate of the reaction.
Hmm.
Yeah.
Got it.
And also temperature can make a reaction go faster. So
Right.
temperature could also be considered. Oh, and also if the catalyst you have has a higher surface area,
Hmm.
that will also cause the reaction to proceed faster.
Okay.
So
So,
yeah,
so temperature, surface area are all kinetic control,
yeah, and primarily activation energy. Yeah,
activation energy, right?
and
Got it.
kinetics
Okay.
deals with speed
Hmm.
or rate of the reaction, but thermodynamics deals with stability.
Okay. Got it.
So sometimes you'll see like, let's say like you get like two products and one is the thermodynamic control, one is the kinetic control. So the kinetic
Hmm.
control would be the product that forms fastest, and
Okay.
thermodynamic control is the product that forms that's the most stable.
Got it. Okay.
Okay. Now, in this passage, they're
Hmm.
telling us that so we have 60% of compound 4A and 40% of compound 4B, right?
Right.
Now, that's not enough for us to figure out if this is thermodynamic control or kinetic control, but
Hmm.
they do tell us that when you do this last step, that you get
Yeah.
thermodynamic mixture of 4A and 4B.
Hmm.
So we know that, so now we know that it's showing us the thermodynamic control. And so compound 4A is 60% of the product is compound 4A. And if
Hmm.
this is a thermodynamic mixture, it means that compound 4A is going to be more
More
stable
stable.
than compound B.
Got it. Okay.
Mhm.
Oh, okay. I also have a problem with like I'll read it and then picking out stuff from the passage
Yeah,
is a little difficult.
I call that buzzwords. I don't
Buzzwords, right? Yeah.
do that in some of my videos,
Yeah.
but like
Mm.
that means as you read something like a passage, you'll be able to see um like words. You'll be able to recognize words because the fact of the matter is that all of these passages they come from published papers from like
Right, right.
these and doctorates. So
Hmm.
we're not expected to know everything here,
Right.
right? We're just expected to know what we're expected to know, like which is
Hmm.
learned in our basic sciences. So
Right.
that's a big part of it. Like same thing with cars, like the passages are going to be written by people who are in, that are also perhaps PhDs and stuff in their own you know, subject matter. So,
Hmm.
an art passage will be written for people
Right, right.
studying art and stuff. So we're not expected to know like the jargon of like the art.
Hmm.
We're expected to know what we're expected to know pretty much. So
Got it. Okay.
that plays a role psychologically as well because
Right,
pre-meds are the most like thorough people, you know,
right.
on Earth. So
Yeah.
like read chemists devised the synthetic pathway for the compound alpha catenol.
Hmm.
It makes you feel like, oh crap, I don't know what alpha catenol is. I didn't study enough.
Right.
I can't do well. But
Yeah.
it's okay. You're not expected to know that.
Right.
But when you see this structure, you are expected to know functional groups that are present in the structure.
Hmm.
And yeah, and then I guess I could go forward. So like the first two steps of the preparation of this are illustrated
Hmm.
in scheme A. So we have our compound 1 here, we have our compound 2 here, and you're adding a base here, you're adding a ethanol, you're adding
Hmm.
ethoxide here, and or diethoxide, something like that, to get
Hmm.
this compound 3, right? So we see that compound 1 and 2 must be combined to give you compound 3, right?
Hmm.
So that could have happened by, so there should be an H here, right?
Hmm.
Right?
Yeah. For 4 bonds. Yeah.
Good. And so the base, what do you think this base would do?
Protonate. The hydrogen.
Well,
Or wait.
what do bases do in general?
Neutralize acid.
Wait, what?
Neutralize acid. Or
Well, yeah. But I mean, an acid will neutralize a base, but
yeah.
what do bases do specifically and what do acids do specifically? like KOH,
Mm-hmm.
put it in water, what does it dissociate into?
K and OA.
Yeah,
Oh,
K plus and OH minus.
OH minus. Right, right. Okay.
So um yeah, you're going to be expected to know like, how these things would dissociate like in water, let's
Mm-hmm.
and so it makes hydroxide, right?
Right. Okay. Yeah.
And what does hydroxide want to do?
I feel like I know nothing now. I
It's probably because I'm asking very open-ended questions,
yeah.
but you want to have the ability to understand something to enough to
Mm,
be able to to be able to explain it or understand it in a simple.
right.
So if it's an OH minus,
Mm-hmm.
it doesn't want to stay minus, right?
Mm-hmm.
So what can it do to get rid of the minus?
Protonated
Yeah, right? So now what about, let's see, HCl, is this an acid or a base?
is acid.
So what does this dissociate into?
H plus and Cl minus.
Good. So we don't care about the K plus or the Cl minus, right?
Mm-hmm.
Like those are
It's just the OH and H, right?
right? But you can
Mm-hmm.
see that that a base will make that. I mean, it doesn't always have to make the hydroxide group ion.
Mm-hmm.
That's like the Arrhenius definition, but the Bronsted-Lowry definition is the real definition for acids and bases, and that states that bases get protonated, or bases are proton acceptors,
Bases. Okay.
and acids are proton donors.
For the life of me, I cannot understand that.
Oh,
Like,
what?
like I understand it, but when like recognizing it,
Uh-huh.
I can't.
When you say
But
recognize,
I think
tell me what you mean.
like mm, I guess just like when it's like I keep forgetting or like mixing up the Arrhenius or like the other one, and I'm just like, okay, like acids or proton donors or bases or it's just like I think practice. Like I just have to
Yeah, yeah.
memorize it and get it in my head. So
So basically, what so the Arrhenius definition we're not going to really care that much about. I mean, that's the simplest one where it just says that an Arrhenius base makes
mhm.
hydroxide
Okay.
and Arrhenius acid makes hydronium. Like this H plus is really H3O plus hydronium,
Right, right.
but you could have a base that doesn't make a hydroxide ion, right? Like if you
Hmm.
had yeah, if you had like so the Bronsted-Lowry definition is going to be your definition for acids and bases, and that means an acid will donate protons
Hmm.
and a base
Okay.
will accept protons.
Okay.
So if you think about the amino acids, like do you remember which ones were the acidic amino acids?
Yeah, E and D, so it's uh oh
Uh-huh.
my God. Glutamine and arginine.
So
Wait,
they
is that the other one?
so it'll be glutamic acid and aspartic acid, and
Yeah,
they have a so what functional group is this?
carboxylic acid.
Excellent. Now, what does it do?
What does it do?
Yep. It's the same thing that all of these acids do.
Deprotonate.
Sorry?
Deprotonate.
Themselves, right? They get deprotonated because proton donors, right?
Mm-hmm. Oh. Yeah.
So
Oh.
it deprotonates, giving you this. So this is the carboxylic acid.
Mm-hmm.
And when it loses its proton, it's the carboxylate
Right.
ion, right?
Right.
What is more stable, this or this?
Carboxylate.
Now, so same thing on the left.
Yeah.
Now, if it was more stable, why would it want to donate the protons to be the thing on the right? Right? If
Right. Yeah.
if it was more stable when it was protonated,
Mm-hmm.
and acids are defined by giving away protons,
Mm-hmm.
it should be more stable after it gives away the proton, right?
Right.
Now,
Yeah.
I'll show you why, because that's another thing. Like, you could only learn so much from being told, like, what?
Mm-hmm.
You know the why, you can figure out all of that other stuff. So,
Right.
check this out. This negative charge here can go here. The double bond can go here. And you would get this.
Yeah. Right.
What is this called?
Resonant.
Yep. And resonance will always stabilize a molecule.
Right.
The idea is that so for this, the carboxylic acid part, if you were to
Mm-hmm.
view the electrons, like we know that oxygen is electronegative, so it's going to pull electron density towards itself.
Mm-hmm.
And that means that if we just looked at the electrons here, there would be a bunch at this oxygen and a bunch at this oxygen, right?
Right.
Now, given that, so another word for resonance is, well, there's a bunch of words, but another word could be electron delocalization.
Mm.
What do you think that would mean?
Uh, Probably like moving the electron around
So yeah, so like,
or getting rid of it.
well, so here in what I drew in pink
Mm-hmm.
shows that the electrons are localized, like
Mm-hmm.
their locations are where the two oxygens are, right?
Right.
But when we do the resonance, the electrons are spread. Oh, I forgot to put that oxygen here. The electrons are spread over a wider area,
Mm-hmm.
right? Instead of it being just at two oxygens that are separated by a carbon,
Right.
the electron orbital encompasses both of the oxygens and that carbon in the middle.
Mm-hmm.
And that means that the electron is no longer localized at specific points. Rather, it's delocalized. It's spread
To only one. Right. Okay.
across a larger area.
Got it.
So whenever you have a charge spread apart over a larger area,
Mm-hmm.
you're going to get um, electron delocalization. It's
Got it.
spread apart.
Okay.
That makes it more stable.
Oh, got it.
Mhm. Good. So now you see that, so again, Bronze-Lary acid donates protons, Bronze-Lary
Right.
base accepts protons. So when we look at this reaction here, we see that this KOH is a base, and
Mm-hmm.
what bases do, they take electrons, right?
Yeah. Proton acceptor. Right.
What can happen here is that this OH minus can pluck off this hydrogen.
Mm-hmm.
And that will give you
Oh.
something like this with a negative charge here, right?
Mm.
And
Why would, sorry, one second. Why would the negative charge not be on the carb?
oh,
Like
sorry,
where the it, oh,
it's over here, yeah.
okay, gotcha.
Yep. So okay, that's now negatively charged. Now, what this can mean is that oh yeah, one sec. Sorry. Okay, sorry.
Yeah, you're good.
So okay, so now it makes sense that this is a negative here.
Mm-hmm.
All right. Now this means that it can act as a nucleophile,
Right.
which means that it will attack something that's like a partial positive, but
Mm-hmm.
since we see that we're adding this group here,
Mm-hmm.
right? That could be this, I use like green, attacking that,
Yeah.
forming a bond with it. So this is 1, 2, 3, 4 carbons.
Mm-hmm.
1, 2, 3, 4 carbons, and then this is the bond with, I'll use orange. This carbon is this one.
So what happens to the double bond that's on compound two?
Oh yeah, so when it makes
Mm.
that bond over here,
Uh-huh.
like that double bond will so you're taking this negatively charged part and you're creating a bond here. So it's going to remove that double bond because this
Okay.
double bond it's connected to it's a carbon connected to two hydrogens.
Right, right.
And so like so for instance, like double bond here is CH2.
Yeah.
And if something like this were to bond with this, right, it would
Mm-hmm.
make that to because this is carbon's already bound to four things. In order for
Mm-hmm.
this to bind to this to make that new bond, this double bond would have to break essentially.
Got it. Okay.
So that's why you have this over here, and you can see that it's
Okay.
added to it.
Right.
And okay, and then so we get compound 3, and then we have step 2 where we add base again
Mm-hmm.
and ethanol here. And it seems like what happens is this that I circled here turns into a ring here.
Right.
So how can that work? Well, this CH3 part, so here, let me draw that like this. The base is going to, so the OH minus,
Mm-hmm.
going to, here, I'll write H2 and then an H like this. This is going to take that proton away from here,
Right.
right? And then this electrons can come here. So you'll get basically that negative charge here,
Mm. Okay.
right? And then that can act as a nucleophile, which would attack the carbonyl carbon here.
Because
Oh yeah. So generally speaking, so the most common nucleophile that you'll see on this exam
Hmm.
is going to be an OH group.
Okay.
And the most common electrophile you'll see in the exam would be a carbonyl group, which is a carbon double bonded to an oxygen.
Okay. Got
Now, so this means that the carbon here, there's a dipole, right? This carbon here will have its electrons be taken away by oxygen. So the
it. Hmm.
polarity here, and at the carbon, there's a partial positive charge.
Yeah.
And at the oxygen, there's a partial negative charge. So
Right.
so now nucleophiles could be considered to be Lewis bases.
Hmm.
And so this would attack here, pushing this up here, and then this comes back down and it pushes away that leaving group. So
Hmm.
so here it's pretty much the same thing, except our nucleophile, instead of it being the hydroxyl group, is just the negatively charged carbon.
Okay.
And but it'll still act as a nucleophile, and it will still attack a carbonyl carbon, which it does over here.
Right.
So what we have happening is that this attacks that,
So like, yeah. Got it. Okay.
and when it does that, it closes the ring to give
Hmm.
you your product here.
Right.
So like for instance, um so it'll close that ring. So like for instance, this pink oxygen here is
Hmm.
pink oxygen here,
Right. Okay.
but this green oxygen like it goes away because when you form this bond here, that's gonna give you it'll look like, let's see,
So.
it would
Hmm.
be like this without that double bond.
Hmm.
This like reflux here means that this OH group will get plucked off and
Okay.
create that double bond. So that's
Got
what
it.
we have here. And yeah, that's how you get these compounds.
Okay.
Um so yes, all in all, that's what happens. And so they actually describe what happens down here. I didn't realize that.
Hmm.
So step one involves, so yeah, if you weren't able to tell just from what we did here, it tells you
Hmm.
that step one involves the base promoted nucleophilic addition of compound one to compound two. So now we know that the base makes compound one, does something to compound one to turn it into a nucleophile, which
Right.
lets it attack compound two, and that's what we
Right.
do here. And then you get compound
Hmm.
three, and compound three cyclizes, turns into a ring
Hmm.
via an intramolecular aldol condensation reaction. And that's really just like, so, you know, a an aldehyde bound to something like this to give you, so you have your aldehyde and your alcohol, and this is your aldol,
Right. Right.
right? Now, there's the condensation step. Condensation is the same thing as, well, when you're losing a water, because it's the same thing as dehydration synthesis, right?
Mm. Right.
So what happens here is that, so if we have the aldol here, what happens is this OH group can get protonated to turn into water, which is a great leaving group, and then this can leave. Or rather, when this leaves, the electrons from this bond can go here to create that double bond.
The double bond. Right.
So
Hmm.
to give you, something like that.
Yeah.
Now, so that shows that there's the aldol step that makes the aldol,
Hmm.
followed by the condensation step, which removes the H2O, giving you that double bond.
Got it. Okay.
So, okay, intramolecular aldol condensation reaction. And then we have the cyclized product, which is not shown, undergoes a dehydration reaction to form this thermodynamic mixture of the isomeric products 4A and 4B. And then they separated them through some means, and then they found that 4A was eventually converted into the alpha catenol that we have at the very end.
Yeah.
So the thing, I guess, so the step that they're not showing us is that cyclized product
right. Step
before
2.
the dehydration. So
Okay.
that would be like basically like something like something like this over here, and that, and then this is that H, and then this is that thing, this is the CH2, but you'll get an OH here.
Right.
And then in the condensation, this OH part
That
leaves
OH goes away. Right.
bond, and that gives you that. Yeah.
Got it. Okay.
Okay.
All
So,
right.
yep. So yeah,
Sounds
that's the passage.
good.
Any questions here?
Not anything so far.
Sure. Okay.
This one. Yeah. Okay. Wait. So
Oh yeah.
I think we just went over this. So
Uh-huh.
um.
Yeah, so you could see how, they wrote like this ketone or whatever here.
Yeah.
How the base deprotonates. Oh, and by the way, this is called an alpha carbon,
Yeah.
and the hydrogens are alpha hydrogens.
Right.
And they're going to kind of be slightly acidic because
Okay.
the oxygen inductive effect, pulling electrons towards itself, makes the hydrogens have less electron density, which means they want to leave. They're not like happy. And so you get, this, and then this can attack that. So yeah, so this is essentially asking for what we got over here.
Right.
See how it's
So yeah. The same one, right? Yep.
So
Okay, that makes sense.
yeah, so this is the after the aldol condensation, or without the dehydration step of it. Yeah.
Yeah. Got it. Yeah, it was. I don't. What did I put this one?
Yeah, so this one over here, like if it didn't have the double bond, yeah, it would be good.
Yeah, I think I was still thinking about the
Oh,
double bond O down here, and I did not. But then also like
yep.
this bond had 5. Okay, yeah, that I think that's why. Okay, yeah, that's why I put it.
Oh yeah, I didn't even.
It had 5, but
Two,
the question
three,
said. Oh,
four,
sorry.
1, 2, 3, 4, 5. Yeah,
So
yep.
so originally I was like, okay, that can't be. But then the question was asking which one is not it. So I was like,
So
I
it's
thought
asking.
that would have.
It's asking, like, if you had the aldol condensate aldol part without the dehydration part, right? So like for instance, this gets this gets protonated, it turns into this, and so
Yeah.
it leaves, and the electrons here can go and make that double bond. That would be the dehydration step. So it's asking what would be that product be after the aldol.
Okay.
So
But not before the dehydration.
yeah, because the cyclization is what happens through the aldol.
Yeah.
And the dehydration is what happens to get rid of the all part of the aldol and to make that double bond. Yeah.
Got it. Okay.
That
makes
but
sense.
also, as you said, right, there's 5 bonds here, and carbon can only make 4.
Right.
So
Yeah, that was my only thing. I was like, wait, what I think what I was just like so fixated on the word not, and I was like, okay, this
Mhm.
obviously can't be it, but I need to
Yeah, yeah, yeah. You
read
want
it properly.
because the MCAT is all about like the nuance in language. Like that's why it's all
Right.
acid based, right? And that's also why
Yeah, yeah.
ours is there, right? Like why is
Right.
there, you know? But
Hmm.
there's so many questions that are just that are wrong or right because of like some specific word. So you
Right.
be very, very nuanced,
Hmm.
have a nuanced understanding of the words used.
Yeah. Okay. Um,
Oh, okay. So,
this one,
uh-huh. So this
I'm
is
trying to remember.
so this is just saying that um that if they instead of using so compound two is this,
Yeah.
and they're
Oh,
saying
they had an extra carbon.
so it'll basically so now they're saying final products of steps one and two. Um
So compound three, like, or after it cyclizes.
yeah, so it'll be like this.
Yeah.
So the only real difference here is that this is another CH3 group, right?
Yeah.
So and that's the part that like so I'll use green again. So
I,
this carbon
mhm.
is this one.
Yeah, I think for this one, I wasn't seeing how the CH3 that they added was coming out of one of the carbons. I was thinking it was like an addition to it. Like how there's one, two, three, four, right, in the original, like four carbons, but then and then they had the original CH3.
Uh-huh.
Or wait, yeah, wait,
Yeah, so this
like this bond.
carbon is this one.
Yeah. So then this bond, I was thinking it would, since there's an extra carbon, it would be one, two, three, four, five, and then a sixth carbon coming out. I thought it was all gonna be like one
Uh-huh.
under one. I can't see where this would come out, like here.
Oh yeah, so like so do we agree that this green carbon is this one, which is this one?
Yeah.
And here we see that I'll use pink again. So this is attached to the green carbon, right?
Yes. Oh. Okay. Yeah.
So this is the
I
CH
see. I see now. Okay.
would have to be attached to the green,
Mm,
right?
yeah. Okay. That makes so much. Yeah. Mm, mm-mm. Oh, how did I miss that? Okay.
It's a tough one, organic, you know.
Yeah. Okay. Oh wow. Okay. So then, okay, we'll just come out here then. What did I put? Yeah, I don't know why I put that. I
See.
think I was just guessing to be honest, but
I see. Okay.
this one, okay, that makes sense. Okay. Uh, this one, I'm good. Physics, I think I just need to memorize the what's it called? Equations.
Well, yeah, you definitely
Like keep practicing it.
are you using Anki?
I was, and then I just been focusing on. I think I'm not finding time. That's a lot. I could be doing it, but
So the
doing like the AAMC like practice questions. So I've just kind of been
so the
focusing on that, but I can add.
so the thing with Anki is that almost everyone like thinks that the way to do it is like because is to do like however many cards, like doing it by the number of cards, and
Mhm.
that can get easily overwhelming. If you miss a day, you have like 3,000 cards.
Yeah, yeah.
So the best way to use Anki isn't going to be in terms of how many cards you did, but how much time you're spending. So I have my students do Anki every day, 45 minutes to an hour. That's it.
Okay.
Because the point
Mm,
of Anki
mhm.
is to, I mean, there's no better way to get things into your long-term memory.
Right.
And so let's say that this is like 100, let's say you're asked to memorize a list, and on day 0 you remember 100% of that list, but there's a forgetting.
Yeah.
So
Right.
like by day 1 you might be remembering like 60% of it.
Right. Right.
But the thing is with Anki is, since if you know something, you'll say that it's easy and it won't show it to you again for like, you know, a longer period of time. But if it's something that you find hard, it'll show it to you with a greater frequency. So
Yeah.
forgetting things, like if you're forgetting 40% on day 1, you do Anki, you bring yourself up back to 100%, and then
Right.
that decays again. And then like,
Mm.
let's say on
Keep
day
going. Right.
or something, you know,
Yeah.
you're back at 60%, you do Anki, you bring yourself back up to 100%. And this
Got it.
forgetting
Okay.
curve just gets flatter and flatter and flatter.
Right.
That's
Right.
how, and that means it's entering into your long-term memory.
Got it.
So
Okay.
I would want you to implement from now on
Yeah.
45 minutes to an hour of Anki a day.
Okay.
And particularly in the stuff that you like don't have memorized, like
Hmm.
like are you using like I guess what deck are you using?
The miles down that.
Okay. There's the essential equations deck
Yeah.
in that deck or whatever.
Hmm.
So I think it's only like 60 cards or something. So you could use that to get all of the formulas down.
Okay. Got it.
And uh
And mhm.
yeah, and then that can help you with formulas, but you also want to be able to be like understand the units, because if
Yeah.
you don't remember a formula, the units will guide you. If you don't remember the unit,
Right. Right.
formula will guide you.
Right.
So now this question, so okay, some of
Oh,
the
this. Mm,
the formulas could be kind of annoying. So
mm,
ultimately, you want to have a conceptual understanding of the formulas and how they're relevant.
yeah. This one, I think. This one, I know the Doppler effect.
Uh-huh.
Yeah.
What about it?
Sorry.
Oh, what about it?
Are you asking me what the Doppler effect is? Or
Oh,
like,
you said that you remembered this one was Doppler and I or something, and I think and I'm just asking, like, what do you mean?
oh, I was just like going through the question, but
Oh, you got this one right. Do you
yeah,
understand?
yeah, yeah, yeah. I got this one. I think I just stopped here to ask about the equations, like for the
Got
physics equations. So, but I just had a question for Anki. If I'm like, I know you said more spending more time rather than how many cards I do.
it.
What about the review cards? Like, is there an option to just do mm, like if it takes me like 20 minutes, like okay, 40 minutes to do like 20 cards, which probably not, but 20 cards, and then I have to review those 20 cards on top of the new cards, would it take longer? No, right? Because
You'll just, yeah, the time, the how long it takes is going to be the measure that we use. So
mhm,
if you get through 15 cards, if you get through 80 cards, doesn't matter as
mhm.
long as you're just doing uh like 45 minutes to an hour every day.
Okay, okay, got it.
Yeah. Um,
And then
fun.
no, I'm just making kind of a list because
Mhm.
these next, I don't know, 1.5 weeks, like I'm trying to do as much as I can to
Yep,
get a decent score, which
yep, yep.
I don't know. Do you think it's possible? Like,
Yeah, of course. Uh,
I'm just kind of stressing out, but
yeah, totally, totally. Yeah, no, it's definitely possible. And yeah, and now that you know how to approach Anki, that's gonna make a big
Yeah.
difference.
Okay.
So yeah, and then yeah, so I would start off with those essential equations, that deck. And
Okay.
if we find some other stuff
Right.
that would be good for you to work on, we can go over that as well. But here ultimately what we're doing here is oh yeah, let's hide the solution. Let's see what the other choices say. So yeah.
Yeah, this
So
one is fine, but
yeah, right. So the observed frequency is the F prime, and then
yeah,
the actual frequency is F. And if it's let's see,
if I'm passing it, then I
passing
prime. Yeah.
I, uh yeah, as you so if it's before passing it, we're approaching it, and so the
Yeah.
observed frequency is going to be higher. And
Yep.
then at right when you're at the same, like,
It's gonna be equal.
it'll be equal, and then when it
Yep.
passes and
Got
starts
it.
to move away from you, it'll be smaller. Yeah.
Right. Got it. Okay. This one is fine. Yeah. Yeah. This one is also fine. This one I reviewed and I get it now because also we talked earlier about thermodynamic stability. So, but I think my only thing was I was between boiling point and heats of combustion because of temperature.
So, so okay, what did we talk about earlier when I was like talking about the thermodynamic quantities? What are some thermodynamic quantities?
So like Gibbs free
Okay.
energy and then enthalpy.
All right. All right. Now, any of these choices involve an enthalpy? Uh-huh.
D.
Yeah, right. Because you could have heat of formation or
Yeah, and heat of right.
combustion and
Got it.
straight up
Okay.
that, right?
Yeah.
So
Okay.
is this also is the bond energy, right?
Right. Right.
Whereas so boiling points are ways to separate things, like it's like distillation, right? You can
Yeah. Yeah.
separate things based on their different boiling points, right?
Right.
Boiling points are determined by intermolecular forces,
Yeah.
right? And what's the strongest intermolecular force?
Hydrogen H bonds.
Yep. So let's say you had ethanol here, or let's say you had ethyl chloride.
Mhm.
Which do you think will have a higher boiling point?
Oh wait,
Yep. Why?
because the H bond,
Yeah.
the hydrogen bonding.
Yep. It can participate in hydrogen bonding. And you know about Fon, right?
No. Well, I mean fluorine,
Oh, like
oxygen, and I.
them together like this. So these are the
Sorry.
atoms that can participate in hydrogen bonding.
Oh yeah, 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 yeah. Okay.
Yeah.
Yeah.
So, okay. So boiling points are essentially giving you information about intermolecular forces, um, which doesn't, like, thermodynamic stability. We're talking about the bonds that are intramolecular, like covalent
Hmm.
bonds, right?
Yeah.
But not intermolecular. So, okay, A would be out. What can you tell me about UV-Vis?
Is UV it's like isn't that when it's going towards the polar side versus
Well,
non-polar?
so first, this is a type of, so like the electromagnetic spectrum, right?
Yeah.
Is AKA light, right?
Yep.
And let's say we have visible light. And let's say, like, going to the right is increasing in energy,
Hmm.
which means what happens to frequency and what happens to wavelength.
Frequency goes up and wavelength goes down.
Good. So do you remember what the order would be for visible light in terms of colors?
Roy G. Bev, so red, orange, yellow. Yep.
Now, to the left of red, you would have infrared.
Hmm.
So infra means something I also tell all my students is that 60% of the English language is based on Greek and Latin roots.
Hmm.
Do you happen to know like Spanish or French or Italian or anything like that?
I know Spanish a little
Okay.
bit.
So that can help you out because like, romance languages,
Yeah,
like, why do you think they're called that?
I don't know.
So like
They're just
today when we use the word romance, we're thinking of like love or whatever, but
yeah, yeah.
what it really means is that it's from ancient Rome. And
Mm,
Rome used to, like, the Roman Empire used to include France before it was
hmm.
France, like Gaul is what
Yeah,
we call it, and then Spain,
right.
right? So France and Spain were in the Roman Empire.
Hmm.
When Rome fell, so if they were part of the Roman Empire, then they speak Latin, right?
Yeah,
Because that's the language that they spoke in Rome.
right.
And when the Roman Empire fell, those regions had their own dialects of Latin
Hmm.
that evolved to currently Spanish, French, and of course Italian.
Right.
So since Spanish is a Romance language, a lot of times you can use that to figure out words that you don't know. And
Mm,
that's a big thing because uh in all my like experience of tutoring, like people
hmm.
think that in order to know a word you need to look it up, but you can figure it out also. Like in vivo.
Right.
Now, if you didn't know what that was, what is that in Spanish?
And life.
Life. So
Yeah.
in vivo means in a living creature, right?
Right.
What's the
Right.
what's the other one?
What's the other one?
Yeah. If it's not in vivo, it's what?
In death.
So in vitro.
In vitro. Right. Right. Is that out of like
So what is that in Spanish?
environment? Oh, adentro. I don't know.
Oh, what's window in Spanish?
Oh, I'm not fluent, but I know a little bit.
Yeah, yeah.
Window?
Yeah.
Oh God, I don't know.
What about glass?
Oh,
So
well, maybe I don't know Spanish.
uh-huh.
I
So
did Spanish in high school, but I like.
yeah, yeah.
Oh,
So like window in Spanish is like vitra or something like that.
vent,
Yeah, something like that.
ventana.
So
Oh,
yeah, I could do
my AirPod died. 1 second.
Ventana, Ventiana.
Yeah, ventana, I think.
Yeah. And so in vitro means like in a test tube, and it means in Latin
Mm-hmm.
glass.
Right.
So,
Okay.
but yeah, so infra means less than, which is why
Mm-hmm.
infrared is going to be less than in terms of energy, red,
Mm,
which is why it's here to the left of red.
Right, right. Okay.
What do you think
Got it.
would be to the right here?
UV.
UV, because ultra means more than,
Right.
and it's
So it'd
more
be
than
700 plus.
violet, right?
Oh no, 400 plus.
Oh yeah, like 700,
400 minus.
like
Yeah.
390 or whatever. So
Mm-hmm.
yeah, so UV would be more energy than violet light, right?
Yeah.
And then you have X-rays and
Mm-hmm.
your gamma rays. So if you start to get having your wavelength smaller than visible light, it can start to get dangerous because right now going through us are like radio waves, TV waves,
Yeah, yeah.
all sorts of waves that don't affect us because their wavelengths are so large,
Mm-hmm.
like super large, like
Right.
but if the wavelength is small enough to be so like UV light has wavelength that's on the same order of magnitude as the molecules in our DNA,
Mm-hmm.
which is why like UV radiation, when it touches like skin, um, it's going to mess with the DNA. It's going to cause
Right.
something called thymine dimers, where
Mm.
thymine in the DNA binds to itself, messing
Mm.
that DNA like sequence up.
Got it.
Um,
Okay.
Now, you know what melanin is?
Yeah.
What is it?
Our the pigmentation in our
Yeah.
skin.
So, like, if you ever look up a structure of melanin or any other pigment, you'll notice
Mm-hmm.
that there's going to be a ton of conjugation, which really just means a ton of resonance stabilization. And so what happens is, so this is the top
Mm-hmm.
high yield topic called fluorescence. What that means is, so typically the energy of a photon absorbed will be equal to the energy of a photon emitted. But if the molecule has a lot of conjugation, aka resonance, aka electron delocalization, right?
Yeah.
Um, it can absorb a high energy photon, but through resonance stabilization, it can when you absorb a high energy photon, your electron gets
Yeah.
excited. But the resonance stabilization will allow the electron to relax down to like a lower state, not all the
Mm-hmm.
way, but to a lower state, so that when it then goes from that lower state to the ground state, it'll emit a photon that has less energy.
Mm. Okay.
So melanin has tons of that conjugation. So that means if
Right.
it has melanin, the UV radiation that comes in gets absorbed by the melanin,
Mm-hmm.
then gets emitted as a wavelength that is, or gets emitted as photons that are of lower energy than UV.
Mm.
And what's lower energy than UV? Visible light.
Visible. Right. Right.
So
Oh.
that so this is a type of spectroscopic technique
Mm-hmm.
that involves shooting UV light at some molecule, and then if it absorbs it and then
Oh. Okay. Okay. Okay.
yeah.
Yeah.
So this
Okay.
is to detect conjugation or double bonds, triple bonds.
Mm. Okay.
That's what this is for.
Got it.
And
Okay. Okay.
mass spectrometry is to detect, well, it detects masses, which helps us
Yeah.
detect isotopes.
I said right. Right. Okay.
So um
Yeah.
and yeah. And so thermodynamic stability we can't get from anything other than heat of combustion,
Enthalpy
which can
and
also be heat of,
got it.
formation.
Got it. Okay. Heated combustion, heated formation. Okay. Got it.
Yeah. And yeah, when you're reviewing these, it's good to like if there's even if you got it right, like if there's things in the choices that you don't know to look up
Right, right.
that stuff.
Got it. Got it. Okay. Um, this one. Okay, let me explain this one because this one I kind of did like let me take the process of elimination because all of these choices had hydrogens and the carbon didn't.
Uh-huh.
So that's why I picked the carbon because I was like, okay, what? But I don't know what tritium labeling is.
So one sec, let me get something.
Also, if it's possible, like the last 10 minutes, if we could, or like 5 minutes, like make like a hardcore schedule for me
Oh
so I
yeah.
can stay on top of it because I'm
So
like all over the place. I kind of need some structure. So,
yeah. So yeah, we could totally do that. It's not like you won't need one to be as involved as what I
mhm,
usually do because it's just like the 2 weeks. But yeah, we can definitely
yeah. Okay.
talk about that. But I'm putting an
Mhm.
image in the chat. See, tell me if you got it. Get it? Have you got it?
Yeah. Oh, yeah. I saw on one of your shorts.
Yep. Yeah. Uh, so so she's probably the only cat that has this type of thing on the necklace. You see how it's glowing?
Uh-huh. Yeah, yeah.
That's tritium.
Oh,
And
wow.
funny because like I tell people that I learned about it from the Spider-Man 2 movie, like the Cat Dr. Octopus one. Because
Uh-huh.
when I saw it and like when I was really young, they talked about tritium and how it's super rare.
Yeah.
You could use it for nuclear fusion. So
Right.
and so yeah, it's radioactive. It gives off beta radiation, and
Mm.
that can hit the phosphorus coating around it that can give off that light. Um,
Oh.
so yeah, that's what it is. So it's
Oh,
basically
wow.
just a hydrogen atom because so regular hydrogen is this, right? But if you have hydrogen with, an extra neutron, oh yeah, sorry, that'll give you deuterium.
Yeah, yeah.
It's going to be with a mass of 2. And then a mass of 3 would be your tritium.
Yeah, okay.
Yeah.
Right.
So,
Wow. I completely forgot about that. Okay.
yep. So, okay, they're using it as a radioactive label, and they're trying to, yeah.
Oh, oh. So I'm trying oh wait. Am I just trying to see where I can find three hydrogens on a bond?
All right, wait, sorry, say that.
If I can find where I can find three hydrogens. Oh wait, oh,
So,
never mind.
so
Because
it's
that
just,
would be one hydrogen.
that the 3 just means that it's a hydrogen with a mass of 3,
Uh,
meaning that
right. Okay.
it has 2 extra neutrons.
Right, right.
Now, they're asking like where, so this is the guanine, and they want to be able to measure the rate of biochemical processes that involve the binding or incorporation, which is like binding of guanine,
Mm-hmm.
right?
Yeah.
And they're saying that water is the solvent. So
Mm-hmm.
they're asking where should we put the tritium for us to keep track of where the guanine goes, right?
Mm-hmm.
Now, this hydrogen, these, and these could easily be like
Yeah.
deprotonated in something like
Right, right.
so.
Yeah.
So we want the label to be on the guanine, and for us to be able to track where that guanine goes, we want it to be on a place on the guanine that stays there.
Got it. Okay. Right.
Yeah.
Yeah.
So
Okay.
You know,
That
like all
makes
the
sense.
stuff that we did with like arrows and stuff in organic chem, like this attacks this, goes here.
Yeah, yeah, yeah.
Like technically speaking, if you had like let's say ROH plus, your ketone, and then you get your answer, your result, which is like a carboxylic acid here,
Yeah.
like there's how do we know that it does this thing, right? Because
Hmm.
it's easy for us to just say, hey, let's take this ketone, like let's take acetone nail polish remover, let's take
Yeah.
ethanol, let's mix them together, and maybe you'll end up with a acid, right?
Hmm.
We can do that experiment, right, to see what we put in and what we get out. But the mechanism, which is the arrow pushing, like knowing that the OH group attacks that carbonyl carbon, like
Hmm.
knowing the mechanisms of things, which means the arrow pushing,
Yeah.
we only know that things work that way by labeling particular molecules.
Mm.
So
Okay.
let's say you labeled the oxygen of this alcohol.
Hmm.
You have the oxygen as this part of this carboxylic acid here.
Right.
Means that we know that this alcohol gets incorporated into this carboxylic acid by binding to the central the carbon
Hmm.
carbon.
Yeah.
So radioactive labeling lets us know, like, be able to figure out the mechanism. So yeah. So
Got
here
it.
just, if they label the first position, it means that
Hmm.
guanine must be there.
Okay.
And the other hydrogen
Got it.
leave. So
Got it. Okay. That makes sense.
use the bathroom real quick.
Yeah, yeah.
All right.
Right. I'm just going through to which question I had next because I like reviewed, but I still had some right. So on this, I found my worksheet
Uh-huh.
with everything. So this is fine. I think 26. This one. Okay, I don't know why I put a star next to this, but oh, okay, yeah. Sorry, one second. Okay, I get this now
Okay.
because both of them are. Oh, this one makes sense. think this one. This one was, yeah.
This one, you want to go over?
Yeah.
So, yeah, let's hide the solution. So, what is the identity of a substance that has undergone net reduction after reaction 1 is complete? So, this is asking us for the, so this must be a redox reaction, right?
Mm-hmm.
So,
Yeah.
let's take a look. What's the oxidation state of this O2?
-4.
So the molecule has a charge of 0, so its oxidation state is.
Oh, if it's an individual
Hmm?
molecule, they have 0. Okay. Yeah, yeah. I need to work on. I keep forgetting like oxidation states and how to do it. I know it's like so simple, but I'm just like
Oh yeah.
I
So
keep forgetting how to do them.
yeah, open up your periodic table here. So for instance, so like oxygen here, right? If you want to figure out what type of ion something has or turns into, or if something, whatever its oxidation state is, you can think
Mm-hmm.
about how many valence electrons it has and how many
Mm-hmm.
valence electrons it needs to complete its octet, right?
Yeah.
So, 1, 2, 3, 4, 5, 6, 7, 8, right?
Yep.
So that means oxygen has 6 valence electrons, right?
Yep.
And it can gain, if it gains 1, it'll have 7. If it gains
Mm-hmm.
2, it'll have 8. So it's going to want to
Right.
gain 2, which would mean
It,
it.
sorry, what was the last thing you said?
Oh, that it's going to want to gain 2 electrons to
Right.
complete its octet,
Mm-hmm.
right? But it could technically gain 1 to be like the fluorine.
Mm-hmm.
Hydrogen, though, can only really gain 1 to be like
Right.
helium.
Yeah.
But that's pretty much, yeah. So like carbon, right, has 4 valence electrons and it can gain 4 to be like neon.
Mm-hmm.
So like for instance, CH4, right?
Mm-hmm.
Hydrogen can only be positive 1
Right.
times 4, so positive 4. So the carbon here is going to be negative 4, right?
Yeah.
And that's pretty much.
Oh, okay.
Mhm. Yeah. Or how about, let's say H2 gas can turn into H2O.
Mm-hmm.
H2 gas has an oxidation state of 0, but what about its oxidation state in H2O?
2
Tell me more. Like,
plus 2?
yep. So it'll still be +1 for each, but since the oxygen is what?
Wait,
Yeah.
why wouldn't H2 be plus 2? Since it's like 2, 800.
Yeah, so it has no charge, right?
Uh-huh.
Which means that, I mean, so it'll look like H bonded to H. So
Right.
this could be +1, this could be -1
Oh, okay.
to give
Okay,
you
okay.
0,
Gotcha. Okay.
right? So, okay, for H2O, what's the oxidation state of the oxygen?
-1.
Uh, so the hydrogen, for one hydrogen, it's +1. For two, it'll be 2 times +1 or +2, right?
Oh yeah, yeah.
Which
So
means,
it's -2.
yep,
Got it. Okay.
yeah. So you want to be able
Okay.
to look at, a chemical structure and be able to tell it's like the oxidation states of the atoms within them.
Right. Okay.
Yep.
Got it.
So
Mm,
so here we go from oxygen with an oxidation state of 0 to
mhm.
oxygen here has an oxidation state of what?
Oxygen has a -2.
Good. So it goes the oxygen. So they're saying, okay, net reduction. What's reduction?
Gaining electrons.
Yep. And what's gaining electrons?
Oxygen.
Yep, because it's going from 0 to
Oh,
-2, right?
that's it. Dang, that's it.
Mm-hmm.
Oh, my bad.
Mm-hmm.
Okay. Oh
Yeah,
wow.
right.
Okay.
And
Yeah.
so the NADP plus, that's something that has been oxidized then, right?
Right, because it's losing electrons.
Yeah. And
Okay.
FAD isn't even written here, but I mean FAD, um yeah, I guess.
Would FAD be a oxidizing reagent? Or what is it called? Oxidizing.
So it seems
Yeah.
like the first step, NADPH reacts with FAD to produce NAD plus and FADH minus. So the FADH minus, so okay, first of all, okay, NADH into
Mm-hmm.
NADP plus, but
Mm-hmm.
it's causing FAD to turn into FADH minus. So the NADH to NAD, the NADPH to the NADP plus is losing electrons, right?
Yeah.
And the FAD to the FADH,
Oh, it's gaining electrons.
yeah, so
So it'd be a reduction. Oh,
the NADPH gets oxidized
yeah.
and the FAD gets reduced.
So then why wouldn't the answer be FAD?
So now I guess they say that the FAD minus quickly reacts with O2 and H plus to form FADH and then so like this reaction one it seems to be much more complicated than what they're giving us at first, but here it says that this interacts with the FAD to give you your FADH minus and NADP plus, and
Mm-hmm.
then the it can react with oxygen to form this thing, which then hydroxylates compound 1 or decomposes non-productively to form H2O2. And then pH dependence of the second step, which regenerates FAD, was investigated. So the second step of this regenerates FAD, right?
Right.
So you're,
Oh, okay.
even though they're not really including it in this reaction here, it
Yeah.
does say that it uses, but at the end you're regenerating FAD anyway.
Okay.
So although we
Got
are
it.
reducing it here, we're still
It
oxidizing.
comes back to it. Right, right. Okay.
So
Got it. Got it. Okay.
what's the oxidation state of oxygen and hydrogen peroxide here?
So if H2 is +2, oxygen is -1,
Good.
then the O2 would be -2.
0? You mean?
Wait, what?
You mean 0?
Mm. Oh, just O. Sorry.
Mhm.
Can we go back a little? You said O2 in hydrogen peroxide, right?
Oh, sorry. Yeah, over here. I thought you were talking about this one.
Oh, no, no.
Okay, never mind.
Oh, wait, I'm confused.
Oh, no. I thought you were just talking about something else. Yeah, so it'll be -1 for the oxygen in O2, and then
Yeah,
this one it'll just be 0, right?
yeah.
Okay, good.
Yep. Okay. Sounds good.
Yeah. So
I think this was. Oh,
yeah. So we're gonna have to wrap up.
okay.
But
Oh, I didn't see that.
the thing about the schedule you mentioned, right? So
Yeah, so can I show you? So I have UWorld and I have the AAMC content. I
okay.
want to finish as much as I can of both.
So for AMC, have you done the section bank?
I'm working through it right now. Let me
You know what I
show
mean when I
you.
say section bank, right? Because there's a lot of stuff that
Yeah,
sounds like it.
yeah. Uh,
Yeah.
this one, right?
Yep.
Yeah, I'm working through it right
Oh, you've done it.
now. No, no, that was like months ago. I did like 3 questions.
Okay.
I didn't like, I was just going through it to go through it. But I never like, when I tell you like the first time I studied for it, I had so much going on that
Yeah.
I had like maybe like 2 weeks to like
Okay.
fully actually study. So and my parents were like, just take it to take it, like see how it is, which I know it wasn't like the best option, but
Uh-huh.
I was like, okay, whatever. So I like rushed through everything. I don't even remember. But this time around, I'm like working through everything
Okay.
thoroughly. The only thing I did do like actually was like the practice sets before. Everything else like these questions like I really haven't.
Okay.
So this is where I'm at right now. It's a little scary, but
Mm-hmm. So here.
sorry, what'd you say?
Oh no. So here, I'm gonna make this for you. Let's see.
Okay.
What about the AMC car stuff?
I'm done with the diagnostic practice and the first question pack. I don't know if I haven't started the second question pack yet,
Okay.
and I can actually start showing you.
So the unscored is the only one that you have not taken.
Yes.
Now, I'm gonna have you do something called a blind review. What that means is, like, let's say in CP you get like 20 questions wrong. I want you to write down what those 20 questions are without looking
Okay.
at the answer, right?
Okay.
And then open it with Jack Westin and hide the solutions.
Okay.
And then basically redo the test, except only redo the questions you got wrong,
Mm-hmm.
this time without a time constraint.
Okay. For the full length or any like everything?
For the full length.
Okay. Okay.
So the purpose of this is to separate the questions you got wrong because you really didn't understand them from the
Mm-hmm.
questions you got wrong because you're running out of time. Because
Okay.
you,
Got it.
you didn't get a chance to answer something because of time, it's almost like
Mm-hmm.
wasting it if you like just look at the answer.
Right. Right.
So this means, yeah, so you're gonna do your blind review and you'll probably get some of these 20 questions that you initially got wrong right, let's say there's 10 that are still wrong, then you'll do your regular review where you read the solution.
Mm-hmm.
And let's say there's like 5 wrong still. When we meet, we can go over the 5 that still don't make sense
Okay.
rather than like all of these, right?
Okay.
So
Yeah,
I'm putting
got
that
it.
down for you as well. And then
Okay.
we can have something like, okay, so I'm going to share my screen real quick.
Okay.
You see that?
Um, mm, yeah.
All right, so yep, here we go. So basically, so tomorrow, Anki 45 minutes to an hour, AAMC section bank and AAMC cars passages from that question pack that you still have, and
Okay.
Friday as well. And then Saturday you can take that unscored test,
Okay.
and Sunday you can do your blind review and review of that test. And then,
Mm-hmm.
for the rest of, these days, you can continue this, continue that section bank. uh,
Okay.
along with Anki, along with AAMC cars. And then the day before, you just want to do passive review, go to bed early, and then
Mm-hmm.
you take your test on the 14th. So that's pretty much.
Okay. If uh
Yep.
if I'm because honestly I was planning on finishing this section bin today.
Uh-huh.
So how can we because I still have like okay, based on like AAMC, what I have left is I can
So
put it
you
in the
said you had
chat.
World.
Sorry.
Said you had UWorld.
I do, yeah.
So
Um,
what?
this is what I have. Sorry.
So what you should do is, so yeah, finish that section bank and then use that section bank to determine what content areas you have or what types of questions you're getting wrong.
Okay.
And then when you do UWorld, because there's so much of UWorld, for UWorld, choose those topics or subjects that you're getting wrong from that section bank. It's
Okay.
essentially like a targeted review. Instead of just doing random UWorld stuff, you're going to be,
Right, right.
we don't have time to do it all. You're going to be doing
Okay.
stuff that's most relevant uh
Okay.
as shown by the section bank. Like if you're doing the section bank and you're getting like fluids wrong, buoyant force wrong,
Yeah.
immune system, then you can do your UWorld and type and check the boxes for like, fluids, buoyant force, immune
Okay.
system. So that way you
Got it.
get a
Okay.
targeted review of the UWorld stuff. But
Right.
pretty much it. So and whenever you like, let's say tomorrow you did the Anki 45 minutes to an hour, you could put a strike through.
Okay.
If it turns out that you only did 30 minutes, you can just edit the cell to say 30 minutes and then do the strike.
Okay.
Okay. But
Sure.
this basically shows that it's Anki, 45 minutes to an hour, AAMC section bank, AAMC cars, and then
Okay.
Saturday and Sunday will be your last full length and
Okay.
involving the blind review and review. And then after that, if you haven't completed the if you've completed the AAMC section bank, it'll still be Anki, it'll still be cars, but it'll be UWorld instead of the section bank.
Okay. Got it.
Yep.
And sorry, I know we're running out of time, but I do you think I mean I want to be able to I put in the chat all the AMC stuff that I still have.
Oh,
I want to be able to finish
so the Q packs are
everything.
from the old test, so don't bother with those.
Okay.
Yeah.
So okay. So
Yeah.
the only Q pack I should be doing is the cars one.
Yeah, because that's the only section that hasn't changed from the old test to the new one. Uh,
Okay.
but the independent bank is fine. But yeah, I would prioritize the section bank. Yeah, The section, so
Okay.
basically you're going to be doing the section bank
Hmm.
for the sciences for at least, Thursday, Friday. And
Yeah.
for AMC cars, you're going to be doing the cars Q pack that you have.
Yeah. Okay.
And then from the section bank, you'll identify weaknesses, and
Hmm.
you can then have UWorld populate, passages and section and questions and stuff on
Okay.
those topics.
Okay.
But also, if you wanted to do like the independent Q bank, there's only 50 questions left, and I'm pretty sure it's like, yeah, it shouldn't take you too long to do that. So maybe you can do that as well.
Okay. And
But
then the
yep,
sorry, go ahead.
no, go ahead.
The official Cubing, it's like 30 questions from like each section. Is that also
I think I was maybe confusing that with the independent.
so they have like the independent one and then they have one that's called MCAT official prep online practice questions. And it's like this one has like 30 cars, 30 that one. It's only 120, like I can do it, but I'm just trying to see.
Um, what's in it? Like what topics?
Do it's all the sections. So like there's 30 questions of BB and then 30 questions CP, 30 questions PS, and then 30 questions of cars.
Okay, I see it now.
Yeah.
Oh yeah, yeah, you can do that. And
Okay.
then that was okay, that was the official one. And then the independent one. Like if it has Psych Soc in it, like it's gonna be, yeah, new, so it's relevant. So yeah,
Yeah.
well. So okay, let's have
Okay.
you do that. So like here, this would be AMC like independent, let's say,
Hmm.
slash official. And
Hmm.
maybe that'll be for a day, and then you can do your roll for the rest of the days. It depends on how long it takes you. But yeah, I would
Okay.
prioritize section bank and Anki, of course, and AMC car stuff. And when you're finished with the
Okay.
section bank, you can do the independent questions and the official Q bank. And
Okay.
that I would still prioritize above UWorld. So UWorld would just be if you have, extra time.
Okay. Got you.
Yep.
And then, sorry, two last questions. Do you recommend, like, when do you recommend that we meet again?
Um,
Because I want to be able to, I want to see.
yep.
I feel like like, when I got the 508, I was like, okay, I did improve. But a part of me was like, mentally, I'm not, like, okay, I did improve. So,
Yeah. So let's meet um that day after you do your blind review and regular review, aka Monday.
okay,
So
Monday,
are you available? What's your availability like?
all
On
day, any day.
okay, okay.
Yeah, because I took off of work now. So I'm just dedicating like 10 to 12 hours every single day to just, that's why I'm like, I can do more than what's on the,
Okay, okay. Let's do Monday at 3 p.m. Eastern. Are you in
okay.
Eastern?
Yeah,
And
Monday, 3 p.m.
do you want to do a 2 hour session
Um,
or an hour and a half or an
mm,
hour? What would you prefer?
let's do let's do an hour and a half. Yeah, let's do an hour.
So Monday the 9th at 3 p.m. Eastern until 4:30 Eastern.
Yep.
And and I can also put you in for either Tuesday or a Wednesday. We could do like Wednesday at 3:30 p.m. Eastern. That can be like, our last session before you take your test. Would that work?
Yeah. Yeah, that's fine. You said 3:30.
Yeah, 3:30. And did you want that to be 90 minutes also?
Can I say 90 minutes now, but if we can finish in an hour, is that fine?
Yeah. I could put you in for, I can do that. So so I'll put you in for 90 minutes, Wednesday the 11th at 3:30 Eastern.
Okay, awesome. Thank you so much. I think my biggest problem is like just sticking my head down and actually like getting it. So like I feel like I'm just doing it and I'm not like getting anything, but
Yep.
we'll see. But okay, thank you so much. I'm gonna follow the schedule. And do you prefer email or text? Because like, can I text or email you if I have like any questions?
Yeah. This is my number in the chat.
Okay, 1 second.
And you said you had Zell, right?
I do, yeah.
Okay. So
How much will it be for today?
it should be here. 1 sec. Should be 183.
Okay. I will send that to you. Well, you said 183, right? Okay. Sorry, it's loading. Okay, I sent it. Let me know if you got it.
You sent it through
Zell?
Zell? You were able to find
To
it?
the
Oh, okay. I got it.
yeah. Okay.
Awesome. So let's see. So like after this session, like Zoom is gonna like process the video. So I'm gonna try to upload it as soon as it's processed. If I don't, like by the end of today, you can like send me an email, tell me like, hey, can you upload that video?
Okay, awesome. Thank you so much.
Awesome.
And if I
go on.
if I like have like if I want a session before Monday, could we also do that? But like depending on how like if how my things are going.
Oh,
or
if you want one before Monday, you're saying?
Yeah, like could I text you and see your availability?
Yeah. If I haven't you can do that.
Okay, awesome. Thank you so much.
All right, great. So, yep, I will see you on Monday and maybe even sooner. So, awesome. Good luck on the